Welcome to clickmyproject.com.
Now we are discuss about the product of dual band waveform generator with ultra wide low frequency tuning range. Now we are going to discuss about the abstract of our product. This product presents a novel mixed signal low frequency dual band square triangular waveform generator chip with a wide low frequency tuning range for medical bioelectrical simulation. It consists of a relaxation oscillator comprising a hysteresis limit trigger and a timing integrator, along with frequency divider stages and path selector output for driving an electrode from 16 selectable channels. It was fabricated using Global Foundries 8RF-DM 130nm CMOS process. The supply voltage of the oscillator is plus or minus 12 volt, and then the logic circuit is applied for a 1 volt power supply. The waveform generator output amplitude and frequency will be changed by varying the gate voltage. Using this frequency and amplitude change, the power consumption of waveform generator and frequency divider circuits will be reduced. This process will be improve the phase noise and tuning range. This process is mainly used for battery operated medical devices. Now we are discuss about the flow diagram of our product to obtain the power consumption of waveform generation and medical bioelectrical simulation therapy. Using different 4 modules to obtain the biomedical simulation therapy and waveform generation power consumption. They are waveform generator, frequency division, multiplexers and path selector. The waveform generation unit produces the square and triangular waveform. It is considered as a band 1 output. The square waveform is considered as a voltage WFG, and then the triangular voltage is considered as a voltage int. The band 1 output will be fully dependent on the clock signal. The clock signal consists of clock and clock bar. Band 1 output waveform amplitude and frequency will be changed by varying the input gate voltage. Frequency division circuit is implemented by 16 stages divided by 2 flip-flops. In frequency division block, 2 series connected inverter to generate the clock and clock bar signal. The output of the frequency division is directly applied to the electrode driving circuit. This electrode driving circuit will be produce the band 2 selectable output frequency. Electrode driving circuit contains a multiplexers and path selector. The frequency division output will be multiplexed using multiplexer. This multiplexer output is directly applied to the path selector. Path selector identifies the path from 16 selectable channels to produce the band 2 selectable output frequency. They are denoted by D0. The band 2 will be produced the 2 frequencies. Both frequencies are independent. They are all the flow to obtain the power consumption of waveform generation and medical bioelectrical simulation therapy. Now we are going to discuss about the running procedure of our product. Our product can be implemented by using the Tanner tool EDA version 13.0. Using different cell to implement our product design. Open a tool window to create your own file from file option, new file, new design. Now we are create the design name from given folder. After creating a file, to create a new cell from cell option, New view, create a cell. OK to create a new cell. After creating the cell, to select the add option to add the library files from this banner. Select a file name to view our different cells. We are implement this design using the different 3 cells, cell 0, cell 1, cell 2. Now we are simulate the first cell. Select cell 0, run option, start simulation. Now open a cell 0 output waveform. We tune for input voltage, VWFS for the square waveform generation, V for a triangle waveform generation, V clock is an input. Expand our output waveform using expand option. Now display the clock input. V tune input voltage, V tune 0, another input voltage. VWFG is an square output waveform, and then VINT, V initial is an triangular output waveform. Square output waveform is fully dependent on a V tune 0 input, and then triangular output waveform is fully dependent on a V tune input. Now we are start the simulation of cell 1. Click start simulation. Now display the output waveform of cell 1. Expand this waveform using expand option. Vin is an initial input. The Vout and Vout2 is an output of a mux. This output of a mux is directly applied to the path selector. This is flow under the electrode driving circuit option. This path selection option will be run in cell 2. Select cell 2, start simulation. Now open a final output waveform window. Expand this waveform using expand option. Vin is an input of our product voltage, Vout is an output of our product, Vout bar is an inverse operation of our output using inverter. Thank you for watching this video.